Hello everyone. In the previous video, I went through ionic compounds and instructed you how to write out the formulas and the names. In this video, I'm going to do the same things, but now we're looking at molecules or covalently bonded compounds, as well as acids. And so before I even jump into how to start writing out these chemical formulas or naming the compounds, you need to be familiar with these prefixes. And so most of them are the same they have been ever since you took a geometry course. But the main two that you have to remember and just kind of keep in the back of your mind at all times is going to be mono and di. And so di, in this case, we're using for two. Please don't mistake it with bi, as we would in biology every once in a while. And so now that you have those prefixes memorized, let's move on to actually naming these bad boys. And so remember, a covalent bond or a molecule is created whenever you have two or more nonmetals sharing electrons. And so these are completely different systems than what we were talking about when we talked about ionic compounds. And so remember, ionic compounds are kind of easy to write out, or the formulas are, because we know that these compounds have to be neutrally charged. And so you have to have the same number of positive ions as you do negative ions. So that's why NaCl has to be NaCl and it can't be NaCl2. But the problem arises for these molecules is there are no ions. There are no charges to cancel out. And so when you kind of go through and start talking about how to mix carbon and oxygen, there are so many different ways that you can combine carbons and oxygens because there is no charge situation to kind of set these guidelines. So in ionic complexes, you have to balance out the charges. In molecules, there are no charges. It's all about how can you share these electrons efficiently in order to have everybody have their octet. So when it comes to naming these molecules, you have to specify the number of these elements regardless, again, of which ones you're talking about. And so the way that you kind of go about this is you need to throw the prefix in front of both of the names depending on how many there are. Generally, we write the element from the smallest group first, or again, you kind of write it from left to right. But again, normally you're either going to be given the chemical formula or the chemical name, and you have to write it vice versa. So you'll kind of already know the order. And if not, then we'll tell you. And so the only exception to this rule here is you are going to omit the monoterm if there is only one of the first element. And so I'll show you a few examples of what I'm talking about. But you're going to write down the prefix, then the name of the first element as it appears on the periodic table. Then you're going to write down the prefix for the second element, followed by the base name, followed by "ide." And so it's a similar situation as it was with the ionic complexes. You write down the name, you mark out the ending, replace it with "ide." So, for example, if we are looking at CO2, something you probably are kind of more familiar with. In this case, we are combining carbon and two oxygens. In this case, the carbon, there's only one of them, but as I stated in the bullet point above, if there's only one of the first element, you do not include the term mono. So for this one, we're going to replace the 2 with di. We're going to mark out the "igen" from our oxygen and replace it with "ide" to end up with carbon dioxide. And the second one, we are looking at carbon with 4 chlorines. So again, if we're dealing with only one carbon, because it's the first element listed here, we're going to omit the term mono. We're going to replace that 4 with tetra, drop the "ene," and add an "ide" to chlorine. So you end up with carbon tetrachloride. And this last one here is kind of a mix of these following rules. So here now we're looking at 2 nitrogens and 4 oxygens. Because there's more than one nitrogen, we have to include the prefix here. And so again, 2 is going to be di, 4 is going to be tetra. You're going to drop the ending of the oxygen and add an "ide." So here you're going to have dinitrogen tetraoxide. And so that is the more or less general idea of how to write out both these formulas and the chemical names. So the formulas you're going to have to kind of work backwards if you're getting the chemical form or chemical name, but it's not too difficult because here if you know the prefix, you know carbon tetrachloride, that's 4. If it's dinitrogen tetraoxide, that's a 2, that's a 4, so there's 2 nitrogens, 4 oxygens. The naming part is the more difficult part. And so you need to include the prefixes in chemical compound, in the covalent compound names. So, some hints or words of advice before I move on. Ionic compounds are created by balancing charges. And so if you see anything that has a Roman numerals with a charge in it, it has to be the name of ionic compound, because there is never ever going to be a molecule that has a charge associated with it. And so if you see parentheses with Roman numerals in it, you know you're looking at ionic complex. If you see any prefixes in the name, like mono, di, tri, tetra, so on and so forth, you know you have to be looking at a molecule, because we do not name ionic complexes like that, because they don't need to be called sodium monochloride, because there's only one way to set up a sodium chloride situation with an overall charge or balanced charge. So that brings us to the last naming group here of acids. And so when we talk about acids, there's kind of a few huge indicators on whenever you're looking at an acid. The first one is all acids must include an H in their chemical formula. And the reason for that, again, we'll discuss these later on in much more detail later on, but all acids, in the very general rule, is if you place an acid in water, it will produce an H plus ion. And so in order to produce an H plus ion, then you have to have an hydrogen. And so the other aspect of an acid is it must be in aqueous form. And so whenever I say aqueous, I mean it is dropped in water. And so if you see any other form of these chemical formulas followed by an L or a S or I'm missing one, or a G, then again, they cannot be acids. There is no such thing as a gaseous acid. That is chemical warfare situation you don't want to be involved in. And so when we talk about acids, they can be broken up into two different categories: binary acids and oxyacids. Binary acids are going to be just an H plus with a non-metal. The only one exception I can think about that rule is if you have cyanide in there, because cyanide is a polyatomic ion that again is treated as a single entity, and so technically for cyanic acid you're using an H plus in the Cn minus, which is still an anion, so it's still going to be classified as a binary acid. The other huge indicator is the other form of acids are oxyacids. And so oxyacid is always going to be an H plus and a polyatomic ion. Or not only a polyatomic ion, but an oxygen polyatomic ion. And so basically everything else on that list except for ammonium and cyanide. Oh, and hydronium. And so when we kind of go through and start naming these things out, depending on what kind of acid you have will kind of dictate how they're going to be named. And so first off, binary acids will always include the term hydro. And so it's a huge misconception that a lot of students kind of fall into, but hydro does not mean water. Hydro means hydrogen. And so here, whenever you're naming it as hydro, I'm trying to choose one that's not one of my examples, but hydrofluoric acid, you are basically saying hydrogen plus fluorine gives you your acid. And so throwing the term hydro in there just states that it is hydrogen plus a nonmetal. And so for these, you would just write it out as hydro plus the base name. Instead of ending in "ide," you are going to drop the ending and add an "ic." And then just to be on the safe side, make sure everybody knows what you're talking about, throw the term acid there. And so for HCl, I'm going to use the term hydro, chlorine, drop the "ine," add an "ic," and then throw the term acid. Same thing with HBr. I'm going to name it as hydrobromine, drop the "ine," add an "ic," then the acid. Then H2S, even though I'm still looking at two hydrogens and a sulfur, I'm still just looking at a combination of H pluses and a nonmetal. And so for this one, you would look at hydrosulfuric acid. And so sulfur is one of those ones, it's kind of messy depending on how you name it. So sometimes, again, sulfite and sulfate, you drop the and you add in an "ate" and an "ite." But for this one, I guess someone just decided that sulfic doesn't sound good, and so they keep it as sulfuric. I'm never going to give you a question on an exam or a quiz that will have the options of hydrosulfic or hydrosulfuric acid there. So don't worry about that one too much. And so, one more time. Binary acids. acids that contain just a hydrogen and a nonmetal are going to have the term hydro. That is the one distinction that makes it very plain and obvious that you're looking at a binary acid as opposed to an oxyacid. In oxyacids, because you are dealing with more than just a hydrogen and one nonmetal, that term hydro is omitted. And so, binary acids include hydro. Oxyacids do not include their term hydro. And so whenever you're dealing with your oxyacids, first thing you have to do is memorize your polyatomic ions. And once you know your polyatomic ions, any polyatomic ion ending in the term ate, you're going to drop the ate and you're going to add an ic suffix. If the polyatomic ion ends in ite, you're going to drop the ite and you're going to add a us, like OUS suffix. And so the problem with this, that again, it's just because our brains work kind of on the common sense level sometimes. Whoever came up with this rule was a complete jerk, and he decided to screw with everybody in the future. And so the way your brain is going to initially try to work is if it ends in ite, you're going to try to replace ite with ic, because again, that just makes common sense. But unfortunately, that is not how it works. And so ite becomes us, and ate becomes ic. So for example, when we kind of take a look at these ones here, if you have an oxyacid that contains HNO3, that NO3 is a polyatomic ion, and we call that polyatomic ion nitrate. And so because that is nitrate, we are going to change the ate ending into ic, and then just add the term acid. We are not adding hydro, we are not doing anything else, we're just changing ate to ic. So this becomes nitric acid. In addition to that, if we're looking at H2SO3, you need to know that SO3 is going to be a 2- for 1. But you also need to know that SO3 is sulfite. And so here, you're not going to add hydro or do anything else. You're just going to change ite to us. And so this becomes sulfurous acid. On the other end, your sulfate, you're going to drop the ate and change it to an ic. And so this is going to be sulfuric acid. And so, one thing I need to make 100% perfectly clear is we have sulfuric acid written out as H2SO4. If you were to get this confused, and if you were not listening to me the multiple times I said, do not include the term hydro, and you wrote it out as hydrosulfuric acid, you completely changed that chemical formula. Because remember, hydrosulfuric acid just contains a hydrogen and a sulfur. And so hydrosulfuric acid is just H2S with no oxygens. Sulfuric acid is an H2SO4. So please, you need to pay attention to that prefix hydro. It is one of those more simple things that some students just completely overlook. So don't overlook it. Pay attention to it. And so, writing out the formulas for an acid is basically just working backwards from writing out the names. And so when you look at the name of the acid, the first thing is you need to have H. I mean, H is a requirement. And so the chemical formula is always going to have H, and so you need to be sure to include that inside of your formula. In addition to that, whenever you look at it, and if it's going to be written out kind of differently, and so even though we are talking about molecules, we're talking about things that contain hydrogens and sulfurs and oxygens, so therefore they're technically like covalently bonded, they're not necessarily written in that way. And so because we are dealing with H pluses, they are actually named a little bit more ionic. And so hydro, again, means you are looking at a binary acid. Hydro means you only have a hydrogen and a nonmetal. If you do not see the term hydro, that means you have a hydrogen in some polyatomic ion. And if it does not include the term hydro, you just need to look at the ending of that acid or acid's name. If it ends in an ic, you know you're dealing with the polyatomic ion that ends in ate. If it ends in us, you know you're looking at the polyatomic ion that ends in ite. So, the next suggestion I can tell you after I've told you all this fun stuff now is go through and do a lot of practice. You need to be very, very, very familiar with this nomenclature. You need to be able to go back and forth from the chemical name and from the chemical formula. Because now when we start talking about these word problems and problems that you're going to see on your quizzes and on your homeworks and on the exams, we're not going to spell these out for you anymore. We're not going to say H2SO4 plus H2O gives you whatever the heck it would be. We're going to say, I just messed it all up, sulfuric acid plus dihydrogen monoxide. And so you have to be able to kind of go back and forth in order to write these chemical formulas and write out the balanced equations and do all the other fun stuff that's involved.